Lily, did you still have a question or your hand was still raised? So.
My bad.
Awesome.
I forgot to put it down.
No worries. All right, here we go. So let's start things off. If you're looking at the handout, there's a spot for you to put an example of each of these rules. These are ones that we went over last week, so they should look very familiar to us. There are 4 basic exponent rules. If you need to move forward, that's okay. So our first one is the product rule. Okay, our product rule says when we have 2 terms with the same basis, we add our exponents. So in my example, I had an x to the 4th and an x to the 7th, and I added those 2 exponents to get my new exponent of x to the 11th. Okay, and again, these are review, but if at any time you have questions or you are confused, please let me know. You can use the little raise hand button. The second one is the power rule, and this one's very similar to the first. Our big difference is that there's only one base here. We still have 2 exponents, but they're separated by parentheses. And I'm going to be honest with you, this one is one that we're going to use a lot today. So star that one, make sure you are familiar with it. Our rule says if we have these 2 exponents, we are multiplying them. So here we did 3 times 9 to get our new exponent of 27. Right? Our quotient rule, for some reason, it wouldn't let me write it like this, like the way I actually wanted to write it. So it should look like that. They're the same thing. And this says if you're dividing terms, that we subtract our exponents. So here we had x to the 8th over x to the 6th. We subtract and we get x to the power of 2, or x squared. And then this last one was one that we said was really weird, but we were just going to memorize. We say anything to the 0 power is always 1. Just always is. It's just a weird thing in math that if you see anything to the power of 0, we change the whole thing to 1. And you'll notice that there is no more n. It's just the number 1. All right, I'm going to pause for like 15 seconds just to make sure everybody that wanted to get those rules down got them down, and then we'll move forward. You guys good? You got your rules down?
Yep.
Cool. Yeah, I know. I just went to say something and words did not come out of my mouth. That's where we're at today.
Not English, just noise.
Are you going to be at the basketball game today?
There's a basketball game today?
There's been 3.
You can only be at the basketball game if you're signed up to be a chaperone because of like COVID things. So I can't be. Sorry.
I didn't know there was basketball. I didn't know there were any games.
All right, here we go. So as we move forward, there are 2 additional rules. Now, I'm going to tell you what to fill in these blanks, and then I'll kind of explain. I'll give you kind of like a mini example of what this will look like. So the first thing, if we have multiple terms inside the parentheses, so we're using the power rule. So before we just saw like one term in the power rule, now we're going to see multiple things inside the parentheses. You are going to if there are multiple terms, apply the power rule to everything. Sorry, brain fart. Everything inside the parentheses. So basically the way to think about this is that we're distributing an exponent. Okay, so let me give you a little brief example here. Let's say we have x to the 3rd, y to the 2nd, all in parentheses with a 5 out front, or out back, sorry. Okay, now that 5, that's saying that whole thing inside parentheses is to the 5th power. So what we would do here, we would take this 5, and just like we normally do with distribution, I'm going to distribute it to both parts here. And because we're using our power rule, what are we doing with those exponents? Let's see if our virtual people get it. What are we doing with those exponents? Yeah, thank you. So in class and virtual, we said we're multiplying. So from here, if we did that, we'd get x to the 15th, y to the 10th. Nod your head if you guys are with me.
Would you add those then too?
Great question. We asked, could we add those? You cannot add these once they've multiplied because they have different bases. One's an x and one's a y. If they were both x's, yeah, for sure.
I was like, wait a second.
All right, our second rule, this one's kind of weird, but we are going to see quite a bit again today, is that if there is a coefficient inside the parentheses, you must also distribute the exponent to that number. And remember, our coefficient is just a number out front. So in our parentheses, let's say we had 9x to the 4th all squared. Okay, that 9 is my coefficient. So what our rule says is I need to distribute that that exponent to both the variable and the coefficient. So I'm going to kind of hippity-hoppity, but I'm going to hippity-hoppity it to the x and to this 9. And what people tend to do, they tend to go, oh, 9 times 2 is 18. Wrong.
Oh?
Because what I'm
I thought it's 4 times.
what I'm doing here, I'm doing 9 not times 2. I'm doing 9 to the 2nd.
Wow.
Then it would be 9
Uh-huh.
times 9.
Yep.
So it would not be 18, but it would be the opposite.
Right.
So it would be 81x.
So we're talking in class that 9 squared, that's really 9 times 9. So we could even simplify this a little bit more and say that this is 81x to the 8th.
Yes.
Yep, Amara, you read my mind. All right, I'm going to pause because we're going to use these skills all the time today, so I want to make sure we have a solid foundation. In class people, can you just give me a thumbs up, thumbs down? And then virtual people, can you give me a scale 1 to 10 where you're at, 1 being I'm lost, 10 being I totally get it?
10 out of 10.
Okay, I'll take that. Is there a part that's confusing you, or are you just... Good. Thank you to my people responding. I appreciate that. You guys are good?
10 out of 10.
Cool. All right, then here we go. I am going to move on to our next slide. We're going to get actually into some examples here. So this first example should seem freakishly similar to what we just did. All right. We have all of these things inside parentheses, and then we have an exponent out in front of those parentheses. So all we have to remember is that if you see an exponent out there, we got a hippity-hoppity distributive property to every single term. Now, right now, it looks like G doesn't have an exponent. But it does. What would G's exponent be here? You guys all know? Yeah, Sophia. 1. Good. And my virtual people got it. Yeah, there's a little invisible exponent of 1 here. So when I multiply that 3 to everything, we're going to do m to the 9 times 3, which gives us 27. B to the 2 times 3, which gives us 6. And G to the 1 times 3, which gives us 3. Boom. We got it.
Easy.
All right. So hopefully that one was okay.
That would be the answer.
That would be the answer. That's it. Okay. And I'm going to be honest, guys, that one was kind of a building block, but this next one would be an example of like a 3.0 problem. So as we go through today, you're going to see some 3.0s, some 4.0s. So if you're looking ahead, some of those trickier ones might be 4.0s, but they're all things that we are capable of. If you're in this group, you can do this. Okay. So let's look at this second one. What do you notice is a little bit different with this second example versus the first example? Bryce? Yeah, we got a coefficient, we got a number in there. So we also have to remember to distribute that 4 exponent to the 4 coefficient. So here we go. Hippity-hoppity, boom, boom,
Distributive property.
boom. Now, be careful. Don't fall into the trap. When we distribute that exponent, we're not just doing 4 times 4. We're doing 4 to the 4th power.
So 4 times 4 times 4.
Uh-huh.
Which is a big number that I don't know.
And then we got x to the 12th and y to the 20th. Do you see why that is?
That just it confused me.
You guys see why that is?
Yes.
All right. Now, if you aren't in class, we were just talking about what 4 to the 4th power would look like. That tells us that we multiply 4 by itself 4 times. So that's really 4 times 4 times 4 times 4. So I'll give everybody a moment. If you think you know that, throw it in the chat. Do you already have it?
16 times
I think I
16.
got 256. I don't know if that's even right.
Yeah, so we got it in class and virtual. It was 256. X to the 12th, Y to the 20th. Yay! Good job, you guys. All right, this next one I want you to try. You'll notice that this one's a little bit different because there's this 5 here. Now, when we think about order of operations, remember our order of operations is Pemdas. So we always start with what's in parentheses, then we go to exponents, then we go to multiplication. So this 5 that's being multiplied, that's going to be the last on our priority list because we have all these parentheses and this exponent to deal with first. So for now, I want you guys to kind of ignore this 5, pretend it's not there. And I want you to try and find me what the value of just that part would be. So I'm going to give everybody about a minute or two to try and figure that one out yourself. Again, I will be calling on some people, so make sure you have an answer for me. You're ignoring the 5 for now, just trying to simplify that other part, okay? And if you know it, keep it to yourself, but I will be calling on some people. So get it ready. My virtual peeps, I'm going to walk around the room. I didn't forget about you. I'll be back. Yes.
Oh, I'll just bring him the answer. But
Oh, you think you got it?
this.
Yeah, and then can you simplify that a little bit?
Wait, then distribute that one too.
No. Don't just simplify just that part right now.
Oh,
The
yes.
3 with the, yep.
Okay.
Good so far, yeah. Cautious. Good so far. Okay, over here. You're doing just this part. Ignore the 5 for a moment and just do this part, just like how we did this. Oh, I didn't see it. Oh, so you did the exponents right?
Oh,
Good. Otherwise, awesome job, everybody. You can try it with the 5 tomorrow. We'll go over it, and then you can see at the very end how you did with your answers. All right. I want to know. Henos, can you unmute yourself and tell me what you got?
I tried searching it up and I accidentally left the meat. So I didn't get anything right now. I'm doing it right now though.
Okay, so work through it with me. If we're multiplying this out, remember we're basically using our distributive property, but with exponents. We're ignoring the 5 for now. We're just looking at this part. What would you get when you kind of distribute that exponent?
3h to the 14th power.
H to the 14th, yep. And what about our W?
And w to the 8th power.
W to the 8th. Good. Okay, now I want to pause, though, because we forgot something. We distributed the 2 to the H and to the W. What did we forget to distribute it to?
The 3.
The 3. So we also need a 3 to the 2nd. All right. You with me now, Henos?
Yeah.
All right. Awesome. Thank you. You can turn off your mic. And then I still have this 5 out front. We'll deal with that in a moment. 3 squared. What did that give me, you guys? 9. So I now have 5. I have a 9 in here. H to the 14th, W to the 8th. Now, here's where people go wrong because we're now in this mentality where we distribute everything. But you're only going to multiply the 5 to this 9 coefficient. You're not going to multiply it to every single term. And here's why. Let's imagine, because everything in here is being multiplied to each other. So let's say you had like a 5 out front and you had like a 2 times 3 times 4 in here, okay? You would multiply this all together, then multiply the 5. You wouldn't multiply 5 to all of these and then multiply those together. Then you're going to get a way bigger value than just multiplying the 5 to all of those things one time. Okay, so you don't want to overdo it with that last little bit. So at the very end, we'd be left with 45 h to the 14th, w to the 8th. How we feeling, people?
Kind of.
Okay, Naomi, is there a question or we just still want to practice a little bit more? Sweet, okay. All right, then I'm going to move on for time's sake to this next part. And here's where you're probably freaking out just a little bit because they look horrible. I'm not going to lie to you. They look really scary. But all it is, we're dividing things. This is just the quotient rule. We're just doing the quotient rule a lot. And what our quotient rule says to do, remember, that says to subtract exponents. The only addition, because we have multiple variables in our numerator and denominator, you just have to remember that you're only subtracting exponents that are the same variable or that have the same base. Okay, so what that means, essentially, you're going to deal with all your x's, then you're going to deal with all your y's, then you're going to deal with all your z's, and you're going to deal with each letter separately until you've gone through all of them. Okay, so I'm going to do an example. I'll have you guys help me through an example, and then we'll do one last one, and we'll be done for today. Sound good?
Very good.
What? Well, we can do more if we have time, but you say no. All right. So let's look at this first example. The first example, we're looking at, we have multiple things in our numerator and denominator. We're just going to go letter by letter. So let's start with our x's. We have an x on top and an x on bottom. Because there's a division sign, our rule says to subtract. So, Lily, what would be my new exponent for my x's here?
You said me?
Yeah.
Your new variable?
No, our new exponent for our x's, if we're using our quotient rule here.
2.
2. Yeah, that's it. You got it. Don't overcomplicate it. I feel like sometimes people look at these problems and they're like, oh, there must be more to it. No, we're literally just subtracting. That's it. Okay. Yeah. So then we move on to the y's and we do y to the 10th, y to the 4th. Remember, we subtract those exponents. All we do is 10 minus 4 to give us 6. Yeah. That's it. We're literally subtracting, people. Good, good. And then this q, there's no other like term with q. We're not going to deal on anything with that, so I'm just going to leave the q by itself. Lily, do you have a question? Okay. And that's it. We've simplified it. Ah, so here you were trying the next one, weren't you? Yeah. So this next one, we might notice a couple different things. So first thing that we might notice is that there are coefficients. We have some numbers in front. Now, coefficients, I know that we said all we're doing is subtracting. You're subtracting exponents. Coefficients are a totally different beast. You do what it says to do in the problem when it comes to coefficients. There's a division line. That means you divide those coefficients. Okay, don't make it more complicated than it needs to be. 10 divided by 2 just gives us 5. Maddie, I saw you had your hand up. Did you have
I realized what I was going to say after you said it.
Gotcha. All right. Now I want everybody to pause, or I want you guys to try this on your own. We need, now you doing what we did over here, I want you guys to find the new exponents for x, b, c, and, well, there's only one n, so I'll just leave the n there. Okay, so I'll give everybody a moment. Find your new exponents, and you might notice something weird here. Yeah, Amara's already noticing the weird thing. If you get negatives, you get negatives. Don't change them. Just leave them negative for now. Okay, I'll give everybody a minute. I'm going to walk around. So virtual people, I didn't forget about you. Just, I'll be back. Oh, there's that you're looking at B's exponent. It's 10 minus the invisible one.
I think I got it.
There you go. Those exponents are tiny. I'm sorry. I don't know why it printed so small. Oh,
Me?
I lost track. There we go. Awesome.
Yeah.
Awesome. You guys are killing it. Good job. Okay, we're about ready with our in-class people, virtual people. Oh my gosh, Lily, you already gave me all the answers. Good job. Okay, so our x, our new exponent, would be -2. Our b, our new exponent, would be -5. c, our new exponent, would be 9. And then we just have an n. Now, pause. Remind me, do mathematicians like negative exponents?
No.
No. Mathematicians hate negative exponents. They make us cringe. They're gross. We don't want them in a final answer. So here's where it gets tricky. So if you were tuned out for a second, tune back in, because this is the part where people get confused. Okay? To fix our negative exponents, right now we have 2 that are problematic for us. I have this x and the b. Both are problems for us. The rule with that is that you move these terms to the other side of the fraction and change them from negative to positive. Now, right now you're saying, Miss, there is no fraction. You're right, but how do we make anything into a fraction, guys?
Oh my fault, my fault, my fault. You put a 1 under it.
Put a 1 under it. Now it's a fraction.
Magic.
Right.
Whoa. So now what we have to do, like I said, all we're doing is we're moving the problematic terms, the ones with negative exponents, to the other side and making them positive now. So I'm going to move this x and the b to the other side. I'm not going to move the other ones because those aren't issues. So now I'm left with 5 up top, c to the 9th up top, n up top. The x and the b move to the denominator. And then instead of -2, x now has a +2. And instead of -5, b now has a +5.
So just put them under.
And that's the answer. Yep. So just move them to the other side of the fraction. Now, I'm going to be honest with you. This is probably the part where I lose some people. So how are we feeling after this one?
Makes sense.
Do you have a spot?
I think I 2 by 3.
Do you have a spot that was a little bit iffy for you?
Look, I look at example number 2.
Okay.
And before you can put the line under it, it's 2x, 6b, and then, okay, we divide, we subtract and we get negative. How did the c just move up there? Now there's like 5c and
Well, you always put, when you subtract, you always keep the terms in the numerator. So like the x and the b, they stayed up in the numerator as well. The only reason they're moved to the denominator now is because they were negative after I subtracted.
And 9 was not negative, so that's why it's up there.
Yep.
All right, good enough.
Cool. Amara, I saw you raised your hand. What question do we have?
So for the original problem with the n, if it had an exponent, would you just bring it down since it doesn't have an n under it? For the subtraction part?
If it had an exponent?
Mm-hmm.
So
say
like if
that-
this was like 8 or something?
Yeah, would you just bring that down?
Nope, you just leave that up here because if you brought this, so let's say you have n to the 8 in the numerator. If you move this to the other side, it'd become n to the -8. Because when you flip it, it changes the sign of your exponent, and you don't want that.
So what would you do with the exponent?
You just leave it up there.
Oh,
You just leave it alone. If there's nothing to subtract, it would. So if this was n to the 8 in our final answer, we would just have a little 8 here.
oh. Okay.
Does that make sense, Mara?
Yeah.
Good question. Other questions? You guys feeling okay?
Yeah.
Yeah.
All right. Stick with me. I told you we got one last one. I'm actually going to skip. I made one up. So if you're looking at the handout, this is different than what you have there. Just flip it over to the back side. We have a different problem because that last one, that we just don't have time for that last big long one in the handout. If you're curious about the last one in the handout, I'll post the answer at the end of the day. But we're just going to go through kind of a shortened, condensed version of that last really, really crazy one. This one isn't short. It's longer than our last one, but shorter than the last one on the handout. All right, so the key here, guys, is just take it piece by piece. You don't have to simplify everything at once. I would suggest kind of breaking it up into little parts, and then you're going to want to try and simplify the numerator and the denominator separately, okay? Now, our denominator is pretty much as simplified as it can get, so we're really looking at just simplifying that numerator here. Okay. Now, if I were you, I see these parentheses. My first idea would be to just start distributing. Okay. We know how to do that. We should feel pretty comfortable with that at this point. So I'm going to hippity-hoppity start distributing here. And remember, we also distribute it to the coefficient. And remember, it's not 3 times 3. It's 3 to the 3rd power, which is actually 3 times 3 times 3. So we get 27 x to the 6th. We're multiplying our exponents. And y to the, what's our y's exponent? What's our y's exponent?
15.
Thank you, Amara. Yep, 15. Okay. And I said our denominator, it's pretty much as simplified as we can get it. But I'm going to pause because let's look at this part. What do you guys notice about this part?
There's a 0.
There is a 0. And let's think back. If we go all the way back to our beginning rules here, anything to the 0 power is 1. It doesn't matter if there's multiple things in there. That whole thing is to the 0 power. So this entire part just becomes 1. The whole thing. So it wouldn't matter how many terms you had in here. If you had x, y, z, p, q, r, all to the 0th, it would all just equal 1. Doesn't matter. If it's all to the 0 power, change it to 1. Even if there was a number in there, yep. Even if there's exponents in there, it doesn't matter. There's that 0 power out. What? Yeah, coefficients doesn't matter. If there's a 0 out there, the whole thing becomes 1. All right, I'm going to go through it. We'll see at the very end how you did. I know. It's our speed demon back there. So what happens since this all becomes 1? I really don't even need to include that anymore because 1 times anything, well, that doesn't change the value of our problem, right? 3 times 1 is still just 3. 2 times 1 is still just 2. So I really don't even need to write this 1 anymore. And now we just have it lined up where we have our x's and we have our y's, and we're going to use our quotient rule. So I'll give you guys about 30 seconds here, see if you can get our final answer. Don't type it in the chat. Just get it ready.
I have the answer. For the first time, I have the answer.
I'll be right back. Don't type it in the chat. Just try and get that final answer for me.
I have the answer.
Yep. What? Well, I can figure it out as I get out of it. Close. Wait. What? You copied down the problem wrong. That's an 11, not 4.
Oh my god.
If you're going to make a mistake, that's one thing. Good job.
Yeah.
I have the answer.
Yeah, and then remember, you don't like the negative, so we'll get to that in a moment.
Let me see.
Yeah, go for it. Try it out. See if you get it. Caitlin, can you tell me what you got?
No. Yeah, 'cause remember? No. Remember what you do in the
This is probably
Oh, guys, hold on. Sorry. One more time, Caitlin.
this is probably wrong, but I got 27 times y 13 over x to the 5th power.
Oh my gosh, you even dealt with that negative. That is perfect. Good job. Good job. That's our final answer. If you got that right, awesome job. If you're wondering, there's a middle step there that you maybe missed. When we subtract here, we'd be left with 27x to the negative 5th, y to the 13th. So what Caitlin did at the very end, she said, well, I don't like this negative, so let's just move it to the denominator and make it positive. All right, so we got our final answer. I'm going to pause. That is where we end today. Are there any questions on this material? I'm also going to stop recording.